So in the last classes, we discussed about the definition of signal, classification of signals, operations on signals like time shifting, time scaling, amplitude shifting, amplitude scaling, and complex exponential sinusoidal signals, and singularity of functions and related functions, and basic functions like impulse function, step function, signum function, and ramp function, etc. Now we are going to discuss about the systems, classification of systems, uh, like that, and what are the operations on systems. Like that. See, these are all the signals. And coming to the systems, so how the system is defined, how the system is defined, system. These are all discussed in our earlier classes. So coming to the systems, so these were system. System is defined like this. System is an entity that processes one or more input signals in order to produce one or more output signals. It will take n number of input signals as the input and n number of output m number of here n number of output signals are there. Here m number of input signals are there, like x0, x1, x2 up to xm. These are the input signals, and y0, y1, y2 up to yn. These are the output signals. So it will take this m number of inputs and processes something, and it will give n number of outputs. This is the definition of the system. The system can be defined. It is an entity. System is an entity that processes one or more input signals in order to produce one or more output signals. So these are all the classification of our systems, like classification of our systems. So these were all these things were discussed in our earlier class only. But just for refreshing, I am telling again. So classification of systems, so based on the number of inputs, these are divided as single input, that is SI. Based on the more number of inputs, these are multiple input. Number of outputs, single output, multiple outputs. Types of signal processed, these are continuous time signal and discrete time signal, analog time signal, analog and digital signals, like this. So coming to the types of the systems, how the systems are classified. So causal and non-causal system, linear and non-linear system, time variant and time invariant system, stable and unstable system, static and dynamic system. So what is meant by causal system? A system is said to be causal if its present value of the output signal depends only on the present and past values of the input signal. Already discussed earlier. So output signal, the present value of the output signal depends on the present and past values of the input signal, like y of n equal to x of n plus half of the x of m minus 1. Next, non-causal systems. What are non-causal systems? Non-causal systems are not causal systems. So exact reciprocal of the definition of the causal system is nothing but the definition of the non-causal system. So non-causal system is defined like this. A system is said to be anti-causal or non-causal if the present value of the output signal depends only on the future values of the input signal. Whereas causal system is defined as the present value of the output signal depends on the present and past values of the input signal. But here, non-causal system is the output, the present value of the output depends on the future values of the input signal. So, for example, y of n is equal to x of n plus 1 plus half of x of n minus 1. Then linear and non-linear systems. What is meant by linear system? The system is said to be linear if it satisfies the principle of superposition theorem. Superposition theorem. So for checking the linearity of the given system, first we check the response due to linear combination of inputs, like x1 of t plus x2 of t. See here x1 of t and x2 of t are inputs. So first of all we have to check the linear combination of x1 of t and x2 of t, that is x1 of t plus x2 of t. Okay, then we combine the two outputs linearly in the same manner as the inputs are combined, and again total response is checked. So outputs, linear combination output is some constant into y1 of t plus some constant into y2 of t. So x1 of t plus x2 of t is equal to some constant into y1 of t plus some constant into y2 of t, then that is a linearity condition. So a system is said to be linear if it satisfies the principle of superposition and homogeneity, superposition and homogeneity principle. So this is said to be linear system. And non-linear system. Non-linear system is it is not linear. Okay, it does not obey the principle of superposition and homogeneity, then that is called non-linear system. Next, time invariant and time variant systems. What is meant by time invariant system? A system is said to be time invariant if a time delay or time advance of the input signal leads to a identical time shift in the output signal. So the time delay or advance, whatever it is, of the input signal leads to a identical time shift in the output signal. Time delay means x of t minus t naught, or time advance means x of t plus t naught is equal to the time shift in the output signal, that is y of t. So it is represented like this: y of t is equal to h of x of t minus t naught, or it is equal to h of x t naught x of t, or hs t naught x of t, whatever whatever we can express h into xt of x of t, or hs t naught into x of t. So linear time invariant systems, so special importance for their mathematical tractability. So linear time invariant systems takes a very important role in mathematical equations. Most signal processing applications involve linear time invariant systems. So if you take any signal processing applications, in signal processing application we will use the linear time invariant systems. Then linear time invariant systems can be completely characterized by their impulse responses. It can be completely characterized by the impulse responses. So y of n is equal to transformation of x of n is equal to transformation of sigma k equal to minus infinity to infinity x of k into delta of n minus k. This is linearity principle. Y of n equal to transformation of x of n. X of n can be expressed as sigma k equal to minus infinity to infinity x of k into delta of n minus k. So this is linearity principle. Next, time invariant principle is sigma k equal to minus infinity to infinity x of k into t of delta of n minus k is equal to sigma k equal to minus infinity to infinity x of k into hk of n. Here transformation of delta of n minus k can be represented as hk of n. This is time invariant equation. Next, coming to the stable and unstable systems. What is meant by stable system? How we can say that there is a given system is stable? The system is said to be bibostable. What is meant by bibostable? Bounded input. BI means bounded input. BO means bounded output. So a system is said to be bounded input, bounded output stable if every bounded input results in a bounded output. Here we are giving some limits to the input as well as some outputs. So certain range we are giving, certain range to the input signal as well as the certain range to the output signal. So for all values of t, it is expressed mathematically like this: for all values of t, mod x of t is less than or equal to mx is less than infinity tends to, for all values of t, mod y of t is less than or equal to my is less than infinity. So here the bounded, some boundaries are there. Here the boundary of mx is mod x of t and infinity. So mx is in between x of t, mod x of t and infinity. Similarly, my is in between mod y of t and input. It means that here the input and output are having some boundaries or some limits. So then only you can say that a system is stable system. Then the system is represented by, for example, a system is represented by y of t equal to a into x of t is unstable, such that a is greater than 1. Here, here the reason is, let us assume x of t equal to u of t. What is u of t? U of t equal to 1 for t is greater than or equal to 0. U of t is defined like that. It is a unit step function. Suppose if you take unit step function, so how it is represented? Unit step u of t equal to 1 for t is greater than or equal to 0. It is 0 otherwise. Like that, let us assume x of t is u of t. Then at every instant u of t will keep on multiplying with a, and hence it will not be bounded. So if a is 1 or x of t is 1, then y of t is equal to a. Y of t equal to a. A into u of t is a into 1. So y of t is equal to a, then it is unstable. Then static systems. What is meant by static and what is meant by dynamic? Static system means it is temporary system. That is, it is having it will not have any memory, so that's why it is a memoryless system. If memory is not there, there is no storage, there is no, it is not having any capability of storing anything, so it has no storage devices. Its output signal depends on present values of the input signal. Whatever you are giving the input, it will give the output. It will not store any input value. For example, I of t equal to 1 by r into V of t. Mathematically, it is expressed like this. I of t equal to 1 by r into V of t. It means that it has no memory. It is a memoryless system. It doesn't store anything, any information. So it will, whatever you are giving the input signal, it will give the output signal. Next, dynamic system. These systems are having memory. So a dynamic system possesses memory. It has the storage device. A system is said to possess memory if its output signal depends on past values and future values of the input signal. So it is represented mathematically as I of t equal 1 by L into integral minus infinity to t v of tau d tau. So it has some memory. It is having the storage capability. Okay, so it is a storage device. Dynamic systems are storage devices. Next, memoryless system. Memoryless system means it doesn't have any memory. System is memoryless if the output y of n at every value of n depends only on the input x of n at the same value of n. For example, if we take square function, so y of n equal to simply xn square. Xn is the input signal, yn is the output signal. Square function means it squares the input signal's value. Okay, sine function, or it sines the input signal. So y of n is represented as sine of x of n. Sine of x of n. Next, coming to the discrete time systems. Discrete time systems. We already discussed about the continuous time signals and discrete time signals. What is meant by continuous time signal? It will be continuous for all values of time. That the continuous time signal is continuous for all values of the time. Whereas discrete time signal is defined as it will not be continuous. The continuous signal can be frozen for some time and it can be divided into equal intervals of the time. That is called discrete time signal. Here also the discrete time system is also like that. So here discrete time sequence is a mathematical operation that maps a given input sequence x of n into an output sequence y of n. Okay, so here mathematically it is represented as y of n equal to transformation of x of n. So this is some function. So x of n it will take x of n as the input and it will give the y of n as the output. Here x of n and y of n both are sequences. Why? Because it is discrete time system. So continuous time signal is nothing but a, it represents signal, whereas discrete time represent sequence. So that's why it is a represented t of x of n. Example, discrete time systems moving running average, that is y of n equal to x of n plus x of n minus 1 plus x of n minus 2 plus x of n minus 3, etc. Okay, next coming to the system properties. What are the properties of the system? So here we have 4 to 5 properties of the system are there. So here how H is the system, it will take X of t is the input, Y of t is the output. So this is a continuous time system, whereas this is discrete time system. Whereas X of t is the given input signal, Y of t is the output signal. Here X of n is the given input sequence and Y of n is the output sequence. So notation, let H represents the system. Here H represents the system. X of t tends to Y of t represent a system with input X of t and output Y of t. So here X of t is the input and Y of t is the output. Similarly, here also in discrete time system also represented as H is the system. X of n is represented as input sequence and Y of n is represented as output sequence. Then it has some five properties are there. So first property is stability. Stability is already we discussed about the stable systems. What is meant by stable system? Stable system. A system is said to be stable if and only if the input signal with the bounded limits is tends to the output signal with bounded limits. So that's why you can say that bibu bounded input, b bounded input is equal to bounded output, that is stability. Next, memory or memory less. What is meant by memory system? Present output value depends on future or past input. That is called memory system. Memory system means it has some memory, it has some store, it can store something. That is memory system. That's why present output value depends on future or past input. Memory less system means present output value depends only on present input. Whatever you are giving the input signal, it will give the output signal. Example, memory systems are mathematical representation of memory systems is like this: y of t is equal to 5 into x of t plus integral minus infinity to t x of tau d tau. Similarly, y of n is equal to sigma m equal to n minus 5 to n plus 5 x of n. This is the example for memory systems. Coming to the causal and non-causal property. What is meant by causal and what is meant by non-causal? Causal means present output depends on present or past values of input. Causal means present output depends on present or past values of input. Similarly, non-causal system means present output depends on future values of input. Here, memoryless is tends to causal. We have to note these points. Memoryless is nothing but causal, but causal not necessary be memoryless. So memoryless will become causal, but causal may not become memoryless. Okay, memoryless means the output value depends on future or past input. Causal means present output depends on present or past values of input. Okay. Next, time invariance. Time invariance means time delay or advance of the input. It tends to an identical time shift in the output signal. Let us define the system mapping y of t equal to h of x of t. The system is time invariant. Next, linearity system. Linearity. What is meant by linearity system? A system is said to be linear if it obeys the superposition theorem and homogeneity. So, linear system can be expressed as if x of t tends to x1 of t tends to y1 of t and x2 2 of t tends to y2 of t, then a into x1 of t plus b into x2 of t tends to a into y1 of t plus b into y2 of t. So if it satisfies this expression, it means that a system is said to be linear if it satisfies the superposition theorem and homogeneity. Then only we can say that the system is said to be linear system. Next, coming to the properties of a system. What are the properties of our given system? So here the main properties of the system are causal, linearity property, causal property, and time invariance property. What is meant by causal? Causal means a system is causal, said to be causal if the output at a time only depends on input values up to that time. Okay, system is said to be causal if the output at a time depends on the input values. Linearity. A system is said to be linear if the output of the scaled sum of two input signals is the equivalent scaled sum of output signal. For example, we already discussed about the linearity equation, that is a into x1 of t plus b into x2 of t is tends to a into y1 of t plus b into y2 of t. That is a linearity condition. Next, time invariance. What is meant by time invariance? A system is time invariant if the system's output is the same given the same input signal regardless of time. So a system is said to be time invariant if the system's output is the same given the same input signal regardless of time. So these three are the main properties of our system: causality, linearity, and time invariance. So this is about the so far we discussed about the definition of signals, systems, classification of systems, signals, operations of signals, types of systems, etc. Next important topic we have to cover here is signals and vectors, analogy between signals and vectors. It means that how the signals and vectors are compared, how the signals and vectors are compared. So signals and vectors. So we discussed about the signals and vectors here. So what is meant by signal and what is meant by vector? We already discussed about the signal. What is meant by signal? Signal is nothing but a function of one or more independent variables which contain some information. Which contains some information. How the vector is defined? How the vector is defined? What is meant by vector? It has vector is one such that it has both amplitude and or both magnitude and direction. Then only we can say that it is a vector. What is meant by scalar? It is having only scalar means it is having only direction or only magnitude. Okay, so a vector can be represented as a sum of its components. Sum of its components. A signal can be also represented as a sum of its components. But component of vector, how to define the component of vector? A vector is represented by bold face type, that is specified by its magnitude and its direction. So vector x of magnitude mod x is the magnitude, and vector g of magnitude mod g is the magnitude of vector g. Mod x is the magnitude of vector x. Let the component of vector g along x can be represented as cx. The component of vector g along x. What is component of vector g along x? Here we are taking two vectors. If a vector x is there, vector g is there. So we can write the component of vector g along another vector x as represented as cx. Geometrically, this component in the projection of G on X. Component in the projection of G on X. The component can be obtained by drawing a perpendicular from the tip of G on X and expressed as G equal to Cx plus E. So component of vector G along X is G equal to Cx. G equal to Cx plus E. What is meant by E here? E is some error function. Is some error function. Suppose we can say that if x and y are two vectors, we want to write the component of vector x along y, then we can write this as x equal to some cy plus e. So it is represented like this. Mathematically, it is represented like this. This is vector g. This is a component of vector g along x, that is cx, and e is the error function. Okay, so we can write g as g equal to cx plus e. So this is component of vector g along x. So vector means it has both magnitude and direction. So here we are writing the component of one vector along another vector. One vector along another vector. Here one vector is d and another vector is x. We are writing the component of vector g along the another vector x as g equal to cx plus some error function will be there, that is e. So it is represented like this. Next, component of vector. Here there are infinite ways to express g in terms of x. So for example, we'll take these two examples. Like this, we can take a infinite number of examples. From that infinite number of examples, we can take two examples. For our convenience, we will take two examples. So here, in the first example, g can be expressed as g equal to c into x1 plus error function e1. Similarly, here also g can be expressed as c into x2 plus e2. Here E1 and E2 are called error functions or error vectors. And Cx1 and Cx2 is nothing but G can be expressed as Cx1. G can be expressed as Cx2. So G equal to Cx1 plus E1 and G equal to Cx2 plus E2. Okay, g is represented in terms of x plus another vector which is called the error vector. So g equal to cx1 plus e1, g equal to cx2 plus e2. If we approximate g by cx, so it is called writing the component of one vector along another vector is nothing but approximation. So if we approximate g by cx, then we can express this as g is approximately equal to cx. This is nothing but approximation of g by cx. So g is approximately equal to cx. So g is approximately equal to. It is not equal to. It is approximately. Approximately means either it is nearly equal to g. So cx is nearly equal to g. G is approximately equal to cx. The error in this approximation is the vector e. How to extract this error? Error can be extracted by subtracting this cx from g, the cx from the vector g. So this is approximation of the error. So the error in the approximation in both cases for last figure are e1 equal to g minus cx1 and e2 equal to g minus cx2. In this function, how to extract this e1 equal to g minus cx1. Similarly, e2 equal to g minus cx2. Next, component of vector. So we can mathematically define the component of vector g along x. We take the dot product inner or scalar of two vectors g and x as, here we already know about the dot product, that is g into x. G multiplied by x is equal to mod g. These are the magnitudes. These two are the mod g is magnitude of the vector g, and mod x is the magnitude of vector x. So mod g into mod x into cos theta. So the length of the vector by definition is mod x square. Mod x square is equal to x into x. The length of x dot x. The length of component of g along x is equal to, we can express one vector along another vector as g equal to cx. That's why. So here the length is mod x. That's why you can express this as c into mod x is equal to g into cos theta. Okay, c into mod x. How to c into mod x is nothing but c into mod x is nothing but g. G can be expressed as c into mod x. So c into mod x is equal to g into cos theta, the length of the component of g along x. Multiply both sides by x. Then c into x square is equal to g into x into cos theta, or it is g into x into cos theta is nothing but gx. Therefore, c can be expressed as g into g dot x by x square, or x into x, or 1 by x square into gx. The length of component of g along x is cx. So that is expressed as mod g into cos theta, mod g into cos theta. Okay, so from this expression, again multiplied both sides by mod x, so c into x square, mod x square is equal to mod g into mod x into cos theta, or which is equal to gx, the vector, the dot product of the two vectors gx can be expressed. This is the definition of the dot product. Consider the first figure again, and expression for c. So what is the expression for c? C equal to gx by x dot g dot x by x dot x is equal to 1 by mod x square into g dot x. So this is the figure. Let g and x are perpendicular to each other. It means that two vectors are perpendicular to each other, means these two are orthogonal to each other. Orthogonal. Or what is orthogonality condition? Orthogonal means two vectors are perpendicular to each other. G has a zero component along x, gives g has a zero component, means g equal to c into 0. So g becomes c into 0, or g equal to 0. From equation, g and x are orthogonal if the inner product of two vectors is 0, that is g into x equal to 0. So g into x are orthogonal means these two are perpendicular to each other. Perpendicular to each other means that is orthogonality condition. Perpendicular to each other means these two are perpendicular to each other, means that is nothing but orthogonality. These two vectors are, we can say that these two vectors are in orthogonal. So what is meant by, what is the condition to satisfy the orthogonality condition? That is the dot product of g into x is equal to 0. Vector component and orthogonality can be extended to signals also. So we can say that there is analogy between vectors and signals. Similarly, component of one signal along another signal, we can express component of one vector along another vector. So here also we can extend the same concept to the signals also. Vector component and orthogonality can be extended to signals also. Consider the approximating real signals. Here g of t is the signal in terms of another real signal x of t. So how to express the vector g in g, how to express the component of vector g into another component x, that is g equal to c into x. Here we are taking the signals, so it can be expressed, the signal, the real signal g of t can be approximated or expressed as the component of g of t along the component of x of t is g of t is approximately equal to c into x of t for all values of here t is in between t1 and t2. Here it is limited between t1 and t2. T1 is less than or equal to t is less than or equal to t2. The error E of t in the approximation is given by, here g of t equal to c into x of t plus some error signal is already there, that is E of t. So E of t can be expressed as g of t minus c into x of t if t is in between t1 and t2, or it is 0 otherwise. Next, as energy is the one possible measure of signal size, to minimize the effect of error signal, we need to minimize its size. So size can be minimized. To minimize the effect of error signal, the size of the signal can be minimized, which is its energy over the interval t1 and t2. So EE, error signal EE is equal to integral t1 to t2 e square of t dt. What is e square of t? E square of t is defined as g of t minus c into x of t whole square. So integral t1 to t2 g of t minus c into x of t whole square dt. This is the definite integral with dummy variable t, hence function of c, not t. It is the function of c. For some choice of C, the energy is minimum. So we have to differentiate the EE with respect to E and equate it to 0. So D by dE of EE is equal to 0. Then d by d of E. What is the E expression? Integral t1 to t2 g of t minus c into x of t whole square dt, which is equated to 0. This is a condition for minimizing the error signal. Differentiate error signal EE with respect to E and which is equated to 0. So by differentiating and simplifying this, we will get it can be extracted like this. So d by d of integral t1 t2 g square t. This is a minus b whole. It is in the form of a minus b whole square. So it is a square plus b square minus 2ab. So by extracting this, it will become like this: d by d of integral t1 to t2 g square t dt minus d by d of 2c into integral t1 to t2 g of t x of t dt plus d by d of integral c square into integral t1 to t2 x square of t dt, which is equated to 0. Okay, d by d of g of t. So by simplifying this one, this expression becomes minus 2 into integral t1 t to g of t into x of t dt plus 2 into c into integral t1 to t to x square of t d of t equal to 0. Then from this expression we can extract c. C as we can extract this c as 2 gets cancelled. So c equal to integral t1 to t to g of t x of t dt by integral t1 to t to x square of t dt, or c equal to integral 1 by ex into integral t1 to t to g of t into x of t dt. So this is the expression for error function. Or recall equation for two vectors c equal to g dot x by x into x square, that is 1 by x square into gx. So this is expression for the signals. So error can be minimized like this. So in this is for vectors and this is for signals. So remarkable similarity between behavior of vectors and signals. This is the analogy between signals and vectors. Area under the product of two signals corresponds to the dot product of two vectors. The energy of the signal is the inner product of signal with itself and corresponds to the vector length squared, which is the inner product of the vector with itself. Next, component of a signal. Component of signal, consider the signal equation again, that is c equal to 1 by ex integral t1 to t to g of t x of t dt. Here signal g of t contains a component vector, a component signal c into x of t. C into x of t is the projection of g of t on x of t. If c into x of t is 0, then c equal to 0. Here c into x of t, that is g of t is 0, then c equal to 0. Signal g of t and x of t are orthogonal over the interval t1 and t2. t1 and t2. Okay, we'll stop this class for today. In the next class, we'll discuss the remaining things.